All right, Math 1 1.7 word problem notes. Number 1. Sumali left the hardware store and traveled towards Town Hall at an average speed of 28 miles per hour. So let's write that down. So Sumali, we'll call him S, traveled towards the Town Hall at an average speed of 28 miles per hour. Sometime later, Ted left traveling in the same direction at 35 miles per hour. After traveling for 4 hours, so Ted traveled for 4 hours, he caught up with Sumali. Find the number of hours Sumali traveled before Ted caught up. So we need to find how far or how long Sumali traveled. So the way that I would do this problem is I would say, well, let's find how far Ted traveled. Ted traveled 35 miles per hour for 4 hours, and he traveled 140 miles, right? The way that I did this is I multiplied these two and it equaled that. So they both traveled to the same place, right? So they both traveled over the same distance. And in that same way that we did with Ted, we can say Sumali, his miles per hour times his hours is his distance, is his miles. I guess I have to put an I there so it's not meters. So we now have an equation here that we can solve. So we're going to say we have 28x equals 140. If we divide by 28 on both sides, we have, well, 140 divided by 28, divided by 28, well, that's 5. X equals 5. So we know that Sumali traveled for 5 hours. And let's make sure that's what the problem actually wants. We'll say find the number of hours Sumali traveled before Ted caught up. Alrighty, so that's 5 hours. Find the number of hours Sumali traveled. So 5 hours, we'll put that down here in big. 5 hours. Alrighty, that is number 1. Number 2, Stefan drove to the recycling plant and back. So we'll say there and back. On the trip there, he drove 30 kilometers per hour. 30 kilometers per hour. On the trip back, he went 20 kilometers per hour. How long did the trip there take if the return trip took 3 hours? The return trip took 3 hours, and we want to know how long did the trip there take. So in the same way that we did number 1, we can multiply. We can find how far it was. 20 times 3 is 60. So the trip back was 60 kilometers, so hopefully the trip there was 60 kilometers. Maybe there was a big earthquake or something and it changed, but we're going to say that didn't happen. So now we have an equation here that we can solve. We have 30x equals 60. We divide both sides by 30, and x equals 2. And we're talking about hours, so here we have 2 hours. Let's look back at that problem to make sure we know what we want, or what the answer wants. How long did the trip there take? All right, so the trip there took 2 hours. A lot of the time, the answer is going to be whatever your variable is, but sometimes it ends up wanting you to find like the difference. It could say something like, how much faster was the trip there than the trip back? And in that case, the answer would have been 1, right? So always make sure that whenever you're done, you go back and read that problem to see what the problem says you need, to see what the answer should be. All right. Alrighty, number 3. A passenger plane left Singapore and flew towards the maintenance facility. We'll call this plane A. A jet left 6 hours later, we'll call this one B, flying at 435 kilometers per hour. So plane B traveled at 435 kilometers per hour in an effort to catch up to the passenger plane. After traveling for 4 hours, the jet finally caught up. So we know that he traveled for 4 hours. Find the passenger plane's, good grief, average speed. All right, So we know the speed of the second plane. We know how long the second plane was, or how long they were driving, rather. And we want to know the speed of the first plane. Okay, let's start off by finding the distance. We'll find how many kilometers we were. So we could say, well, we have 435 times 4. We have 1740. So it's 1740 kilometers. So we multiplied there and we got 1740. So we know that this plane traveled 1740 kilometers as well. But we need to know how long was plane A flying, right? So let's reread this again. A passenger plane left Singapore and flew towards the maintenance facility. A jet left 6 hours later, flying at an average of blah, 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 blah. After flying for 4 hours, they finally caught up. So how long was the plane A actually flying? He was flying for 10 hours. Okay, so now we can take this down here, and if we wanted to write this as an equation, this one's kind of nice, and you can easily at least. 10x equals 1740, right? I just pulled this thing here, and I took out all the units, and I got this. This is x equals 174. And to put back on our units, this is kilometers per hour. There that is. All right, number 4. Mike left the movie theater and traveled towards his cabin on the lake at an average speed of 50 kilometers per hour. So Mike traveled at 50 kilometers per hour. Wilbur left sometime later. Wilbur traveling in the opposite direction. Okay, so we're going to need to remember that Mike was traveling forward, Wilbur was traveling the other way. And he had an average speed of 30 kilometers per hour. Okay, after Mike had traveled for 2 hours, so 2 hours, they were 130 kilometers apart. Okay, so they were 130 kilometers apart. Oops, let me rewrite that, not 13, 130. 130 kilometers apart. How far did Wilbur travel? So here, let me rewrite this just a little bit to make it look like last problem. So we have 130 kilometers per hour. I'm going to set that up there. So let's start off by seeing how far did Mike travel. So Mike traveled, if we multiply here, we say equals, then he traveled 100 kilometers, right? Because I have 50 times 2. So if Mike traveled 100 kilometers, in total they traveled 130. Well, that means that Wilbur must have traveled only 30 kilometers, right? So we can fill in here, and we have x hours. So again, to make a pretty equation out of this, we have 30x equals 30. Let me put that back in blue. I didn't mean to be in orange. And we divide by 30, and x equals 1. And we're talking about hours, or just h. Alrighty. Number 5. Michaela left the airport and traveled towards the dump. Daniel left 1 hour later, traveling at 80 kilometers per hour in an effort to catch up. Okay, so we'll have Michaela and Daniel. Daniel traveled at 80 kilometers per hour. After traveling for 4 hours, Daniel caught up. So he traveled for 4 hours, and then they caught up, or 4 hours. What was Michaela's average speed? Okay. So 80 times 4 is going to be, what is that? Is that 3 something? 360? That doesn't sound right. clear. 8 times 4, 320. Okay. So Michaela, we're trying to find out how fast she was walking, or how fast she was going. We know that she traveled 320 kilometers, though. Right? So let's find out how far did Michaela, or how long was Michaela moving for. So let's reread it. Daniel left 1 hour later, and after traveling for 4 hours. So Michaela was traveling a total of 5 hours, right? So I can pull this down and I have x times 5 equals 320. And I don't know why I switched to orange. We can divide both sides by 5. I'm going to take 320 divided by 5, and I get 64. So x equals 64, and we're talking about kilometers per hour. Okay, number 6. A fishing boat traveled to Guam and back. The trip there took 4 hours. So the trip there, we'll say there and back there. The trip there took 4 hours, and the trip back took 6 hours. It averaged 10 kilometers per hour faster on the trip there than on return. So that's a little bit different. So we'll say, so it averaged 10 kilometers per hour faster on the trip there. We'll call x kilometers per hour on the trip back, and it said it was 10 kilometers per hour faster. So we'll say 10 plus x kilometers per hour. Okay, this one's a little bit different. We got that double variable there. What was the fishing boat's average speed on the outbound trip? So we're trying to find x. We know that they both traveled the same distance, right? We know that if you traveled at this and you traveled at this, they have to be equal. So what I'm going to do is I'm going to pull that down in the bottom and I'm going to set them equal. So I'm going to say 4 hours times 10 plus x equals 6 times x. This is 40 plus 4x equals 6x. If I subtract my 4x, I get 40 equals 2x, and then I get 20 equals x. So if 20 is x, we have 20 kilometers per hour there, and 30 kilometers per hour there. Now, what did it actually want? It said the last sentence there says, what was the fishing boat's average speed on the outbound trip? Outbound means leaving trip. So that would be 30. So 30 kilometers per hour. Alrighty. Number 7. Joe drove to the lake and back. It took 1 hour longer to go there than it did to come back. The average speed on the trip was 24 miles per hour. The average speed on the way back was 30. How many hours did the trip take? All right, so this is going to be kind of like number 6, only we know the miles per hour. We don't know the hours. So we'll say there and back. It took 1 hour longer to go there than it did to come back. So we'll say we have x hours in the bottom and x plus 1 hours in the top because it took an hour longer. The average speed on the trip there was 24 miles per hour, and the average speed on the trip back was 30 miles per hour. And just like in number 6 in the last problem, these two guys have to be equal, right? Because if you multiply them together, you have the distance, and the trip there and back isn't going to change while you're there. So I'm going to have 24 times x plus 1 equals 30x, right? All I did was I multiplied these guys together. So I have 24x plus 24 equals 30x. I'm going to put my 24 on the right side, so I'm going to have 24 equals 6x. I divide by 6. What is 24 divided by 6? 24 divided by 6, well, that's 4. So x equals 4. So if we go back up to our problem, we have 4 hours here and 5 hours there, because I just plugged that x in. And to go back to that last sentence of the problem to see what they actually wanted, it said how many hours did the trip there take? Well, the trip there took 5 hours. Alrighty. Last one. An aircraft carrier traveled to St. Vincent and back. It took 1 hour longer to go there than it did to come back. So it said 1 hour longer there. So we have x plus 1 for there. And then for back, we just have plain old x. And we're talking about hours. The average speed of the trip there was 24 kilometers per hour. The average speed on the way back was 27 kilometers per hour. How many hours did the trip there take? So the trip there, we're going to come back to that. So just like the last two, we're going to set these equal and we're going to solve. So 24x plus 1 equals 27x. So 24x plus 24 equals 27. I'm going to put my 24 on the right side. 27x, excuse me. I'm going to have 24 equals 4, 5, 6, 7, 3x. And if I divide by 3 on both sides, I have 24 divided by 3. That's 8. So 8 equals x. I go back up and I plug my 8 in. So I have 8 hours here and 9 hours here. The problem said, how many hours did the trip there take? Well, the trip there took 9 hours. 9 hours. Alrighty, there we are.